Okay, all right. Assalamu alaikum. Today's experiment we are going to discuss about the operation amplifier and its basics. So this experiment is all about the basics of op amp with IC M741. So first, this experiment will cover based on the unity gain buffer and inverting amplifier and summing amplifier. And there is an exercise for you guys that based on the basics that you have understand. So based on your understanding, you will design a positive summing amplifier with an inverting positive summing amplifier to make the signal positive, to make the output of the summing amplifier to make it positive. So this is an experimental task for you guys to deal with it. So first, let's get back to the first of the topic here. So we'll design this unity gain buffer or voltage follower circuit. So first, let's get back to the let's get back to the software platform here. First, we'll take op amp here. Yes. Let's get back to the analog here. We'll select op amp and take the 741 ICs here. So next we will okay, next where's the experiment? Okay, next we will design this circuit. How we will design here, then we'll choose a AC voltages here, AC voltage. Okay, we'll connect it to the positive side of the op amp, non-inverting input of the op amp here. We'll connect it to the ground. Sorry. Then we will connect this feedback here. This feedback connects with the inverting input of the op amp to the output of the op amp here. So it will be, we'll make it, we'll short it down. We'll connect these two ports of this op amp here. First with the inverting input and with the output of the circuit. So we will connect it to the pin number 2 with the pin number 6. Okay, so first before designing the circuit, we have to use the bias voltages here, DC offset voltage. So this is known as the 15 volt plus 15 volt positive DC offset voltage and negative minus 15 volt DC offset voltages here. So we'll apply DC sources here. So the pin numbers are, we'll apply pin number 4 with the negative DC supply and pin number 7 as the positive DC supply voltages here. So we'll get back to here. Just a minute. So this is the DC for DC power. Okay, all right. DC power. it as 15 volt here, and we'll also make it as 15 volt here. Now we will connect it to the ground here. So this is the complete connections here. So now we will, okay, we have connected the feedback. We have applied the DC offset voltages here to the op amp, and this is our input, non-inverting input signal here. And we will see what is the positive, what is the output voltages here. So in order to visualize the signal, we will use an oscilloscope here. Okay, so in this case we will use a Tektronix oscilloscope. Okay, let's run it now, and we will see the signal responses here. Okay, if you see the signal responses from here, we will see. Now we will try to measure these input and output voltages of the unity gain buffer. So our input voltage for the unity gain buffer is, so how we will measure this thing? There's two ways that you have gone through the basics of the oscilloscope before, but there's another way to measure it. So what you guys do, so this is 1 volt peak and this is a 1 volt peak, so it means that our input voltage is 1 volt here and output voltage is 1 volt. So how we are going to measure this thing here from the oscilloscope? So if we go into the measure button here, let's get to the channel 1. So this is our peak to peak voltage. Sorry, just a minute. The peak to peak voltage is 2 volt here. Now we'll set it at maximum volt, that is 999 millivolt, that is almost 1 volt of the peak voltage of this input signal. Now we'll click back to the measure signals here. We'll get back to the channel 2. Here our maximum maximum peak voltage is um, 1 volt. That is also 1 volt here. Now we'll click back to the measure button here. So this is how we measure these signals. So the principle of the unity gain buffer is that our input voltage and output voltage will be same. That is, our total gain for this unity gain buffer will be 1. So this is the basic principle of the unity gain buffer. So so now we will create another another circuit of inverting amp here. We'll build this circuit and we'll create we'll apply 2 volt peak to peak voltage signals and with the 1 kilohertz signal here. So what we're gonna do is close it down. We'll create another RDSyn file here. Now we'll build this circuit. What is the circuit here? Okay. So we will build this circuit. This is our inverting op-amp, inverting amplifier. Sorry. So we'll take similarly we'll use a we'll go back to the analog families here. Under the analog we'll select op-amp. So this is we will use these ICs, op-amp ICs, that is 741 here. This is our basic op-amp circuit. So after selecting the op-amp circuit, now what are the things we need here? We will need 2 resistors. That is, one is input resistor of 1 kilo ohm and that is the feedback resistor of 5 kilo ohm here. So we will select 2 resistors here. We'll get back to the basic options. We'll select the resistor and our input resistor here is 1 kilo ohm. We have selected 1 kilo ohm here. And another for 5 kilo ohm here for the feedback part. Okay, now we will use a ground here. Sorry. We'll connect the feedback resistor to input of the inverting input of the op-amp and the output of the op-amp here. So this is our feed. Now we are using the feedback resistor. In the previous circuit we didn't use any resistors here for the voltage for the unity gain buffer here, but now we are using the feedback resistor because there's an equation there's an equation for this inverting op-amp here. We're going to apply this here. So our equation for this inverting op-amp is let me write it down here. In this case, that would be looks like this here. So if we calculate the voltage gain here, it will be like minus V out by V input equal to minus R feedback resistor by R input. So this is our gain equation for this inverting op-amp here. So that's why we need a feedback resistor here to calculate the gain. So this is one of the way to calculate the gain of the inverting op-amp here. So now we will connect this we will use now we'll use a voltage source here. AC voltage. AC voltage. So it is written that we'll keep it as 1 volt peak to peak, 1 volt peak here, and the signal frequency is 1 kilohertz. Okay, that's fine. We'll use another ground here. Now we'll use the DC source here. DC power in a similar way. Actually, it's not necessary to use underground here. We can connect it here. Now we'll use an oscilloscope here. Tektronix oscilloscope. We connect it to the ground. So one of the channel will be connected to the input. Sorry, just a minute. To the input, and output will be connected to the, and the another channel will be connected to the output here. So now we will see what's the response of the signal response of this inverting op amp here. Now we will run it. Let's see how it looks like. Let me see, just get back to the inverting input here. Okay. All right. I just did a mistake here. Sorry. Okay, now this is our signal. This is our circuit here. So in this case, we have to calculate the. Now in this part, we have to calculate the input peak to peak voltage and output peak to peak voltages here. So we need to remind one thing, that while calculating the gain, we will calculate the. Will not use the while calculating the gain, will not use the input voltage peak to peak here. We'll use the peak voltages here as the input and the output voltage as the peak voltages here. So the gain equation that I've shown it to you here will be like this. So it will be like peak to peak, not the peak to peak voltage. We'll use peak voltages here for the calculating the gain, or we can also use in both ways, but that is what I prefer here to calculate the while calculating the gain. We'll use the peak voltages here, not the peak to peak voltage. So both of the ways are fine, I think. And so let's get back to the circuit here. We'll calculate the gain from here. Okay, we'll use the channel 2 here. So we'll get back to the channel 1 here. Now we'll calculate the input voltages here for the peak to peak voltage. If we click the channel 2, now if we click the peak to peak voltages here, so this is the so this is the channel to peak voltages. We can while calculating the gain, we can use in both ways. We can also apply peak to peak voltage, that is v out peak to peak by v input peak to peak here, or we can also take as v out peak by v input peak voltages there. Both of the ways are correct. So now what we are going to do to fill this form, we will just write down the peak to peak voltages here, both in experiment, both from the hardware results as well as in the simulation. So this is all about the inverting op amp here. Okay, let's close it down. Now our last part of this, so there is a questionnaire here. Now you guys will apply the input voltage as 8 volt peak to peak. This is guys your task from your basic understanding that I've shown you earlier, that what it will look like if you apply 8 volt peak to peak here. You guys write your responses here in this case. So what you'll just do here, just apply go back to the AC voltages here and write the peak voltage. That is if it is 8 volt peak to peak here, just write down the 4 volt peak. That means now the signal will be like 8 volt peak to peak here. Okay, so so our last part of this experiment is the summing amplifier. So what you're going to do, we have to build this circuit just like the other two circuits before. We will use for the inverting input, we'll use 2 resistors here parallelly and 1 feedback resistor here, and we'll try to find out the output voltages of the summing amplifier. The basic principle of the summing amplifier is to add 2 different signals here, and we'll amplify the inverting, will amplify the input signals here, input voltage signals here. So this is our task here in this case. So first we'll build the circuit in another blank blank file. So we will use the analog here is the 741 op amp. Now we will use 2 resistors here in this case. So the resistor 1 is 1 kilo ohm and resistor 2 is 1 kilo ohm here. So we will use 2 resistors here in this case. So now we'll use a ground here. we have missed one thing. We'll have to use two voltage signals here, signal 1 and signal 2. My signal here, my signal 1 will be 8 volt peak to peak, and signal 2 is 2 volt peak to peak. So what we're going to do in this case, we'll use AC voltage here. So our first signal here, signal 1, our signal 1 will be 8 volt peak to peak. So we can choose any one signal as we like, as first signal is 8 volt peak to peak here. So if we consider it as signal 1 here, so it will be like 4 volt peak, and the signal frequency is 1 kilohertz. So now for the signal 2, we'll consider it as 2 volt peak to peak here, so that is, it will be 1 volt peak to peak. It will be same as it is, and our signal frequency is 1 kilohertz. So now we will use a feedback resistors here. Okay, now we'll use two DC offset voltages here. DC power. Now we'll connect it to the ground for the DC offset voltages. Now we'll apply DC offset voltages of 15 volt for both of the cases. And for the inverting op amp, we will connect it to the ground. Non-inverting input will connect it to the ground. Okay, now we'll use a oscilloscope here. Now we will use two channels for the input, and sorry. And the third number channel is the output here. So now we'll run this circuit, what it looks like here. So if we run this circuit here, so what you're going to measure in these cases, so we'll have to calculate the summing amplifier, output voltage of the summing amplifier, and the previous one is for the inverting amplifier here. oh sorry, that equation, there will be no minus here for the inverting op amp. Now it is correct. Channel 2, channel 3. So this is our signals, overall signals here. Channel 3. So what we're going to measure here, we are going to measure the, so this is the previous formula for the inverting amp. Now we are focusing on this. What is the output voltages of this summing amplifier? So our output voltage is the signal 3 here. So we are going to write, we are going to use these equations for the summing, for this summing amplifier, but there is another formula for to write down the summing amplifier voltage. That is our equation. Another equation, there is another equation you guys can use here in this case. That is V output equal to -2, so -2 into V1 plus V2. These are the two input voltages of the summing amplifier here. So we'll measure the peak voltages for the channel 1, that is 4 volt here. Now we'll click on the measure button here. For the channel 2, that is the second input here, our input voltage is our peak voltage for this channel 2 here is almost 1 volt. Okay, all right, that is almost 1 volt here. Now we'll try to see if we apply this formula. So you guys have to see that by applying this formula and from the signal responses, whether your results matches with the signal responses here. So you guys will apply both of the cases to find out the voltages output here by using the equation and from the signal responses. So if you guys click it on maximum voltage here, from here, that is like 5 volt. So our voltage will be like here, will be 5 volt here. So this is our maximum input voltage in this case. But you guys can use this formula here. I think this formula is much more reliable to use this one. Okay, let's remove this one. Let's not focus on this thing here. We'll use the previous formula here. Right. We'll use this formula to calculate the voltages output here in this case. So this is all about the overall experiment in this case. Now there is an experimental task for you guys here. What will you do to make the summing amplifier to make it positive? So you guys what you guys do here in this case, to cascade two operational amplifiers here. first you will guys use this by following this block diagram here. You guys first use the summing amplifier here. Now you will connect the output port of the output pin of the summing amp to the output signal of the inverting op amp. So I will guys share this block diagram, as well as I will guys share this block diagram to the to your instructor, and you will find it out. So what you guys do here in this case, you will guys use a summing amplifier here, connect the output pin to the input to the inverting input of the output signals, inverting input of the inverting op amp here, inverting amplifier here. Now we'll see the now this is now you will see the output signal responses as the positive output here in this case. So you guys have to build the circuit based on this block diagram here in this case. So I think this is all about this experimental task. So if you guys have any question regarding this, you can ask your instructor, or you can leave him or based on your feedback, I will get the feedback from you guys, from your instructor in this case. So thank you. Assalamu alaikum.